Hello everyone, in this video we're gonna containerize our auto-implemented Springboard service without using Dockerfile. Instead, we're using Google Jib. By that, we can build optimized images without knowing Dockerfile's best practices. Improve our continuous deployment pipeline, CD pipeline, and other convenient things listed here fast, reproducible, daemonless. Okay, let's go ahead and apply it to our other service. Since we've been using Gradle, so we'll stick with Jib Gradle plugin here. But if you're using Maven, you can take a look at Maven plugin here. Okay, Gradle. So in Gradle, we can set it up very easily. We only need to add this line into our plugin blocks. Here. So build Gradle. I'm going to add this. Then we reload. And now you see we have Gradle GIB, GIB build tar, and GB Docker build. So we can run Gradle Jib to build and push a container image to a container registry like Google Artifact Registry. So this name is deprecated. Amazon ECR, Docker Hub, JFrog Artifactory, and Azure Container Registry. And for our case, we only need an image locally, so we are going to use Gradle Jib Docker build. Okay, let's try and run it. But before that, let's see the image we created from Dockerfile when we run Docker Composer from last week. Docker images, I'm going to find order in the name. So as you can see, this is the image we had from last week. Now I'm going to clean and build a new image using Jib Docker build. Okay, so new image built order service 0.0.1 snapshot. And let's take a look at some log here. So this is one important thing we need to know, and I will mention it later. So this is the container entry point, that the main process of our containers. So we run java -cp, so this is the class path file, and this is the main class. So keep it in mind, and we'll discuss it later. Take a look from the beginning. So the base image, so we haven't specified any base image. And by default, when the Jib detects that we're using Java 17 here, so this will using a default base image is Tamarind 17 here, and actually, what a coincidence. This also the base image that we use in Dockerfile. Here. Okay. Let's check our image again. Now we have all the service. And this time I'm going to update our Docker Compose of YAML. So instead of build from Dockerfile, then we are going to image. Then I'm going to run doc. Now everything is ready for us. So we have our service here. Okay, let's docker ps. Then we have our service, progress, jiggered, and I would like to see the log. Here you see it took 23 seconds to start our service, and it's because of the requested image lot form doesn't match the detected host lot form here, so it's affects the performance of our application, our service. So you know that I've been using the Mac M1, so the host platform of my Mac M1 is the ARM64, but the image platform is the Linux AMD 64, basically it's good enough because usually we deploy our service to some ADM services, and most of them currently is ADM services like Amazon environment, runtime environment, Azure runtime environment. So most of them basically the AMD in Linux, Oracle also. But in our case, we would like to deploy it in our MacBook M1 chip ARM. Then it's going to affect our application, right? So you see here, it took really much longer time than it should take. Okay, let's try to call it. So we have localhost. So we're going to jigger kernel services, and then we're going to call some other service. Okay, let's check. So it's still there's no trace information from jigger, right? Because we using just the gib docker build, jib docker build here without auto implemented, right? So it's just a plain Java service. That's the reason it can connect to the progress here. It's a Java plain service, but because we haven't auto implement it with OpenTelemetry Java agent, so that's why there's no trace was sent to triggered. So you see, even try to send another and another, and I'm going to refresh this one. So there's no trace showed here. Now, what we want to do is to tell Jib that we want to apply the same logic of our Dockerfile to our build.gradle to achieve the same results as we had with Dockerfile. So to do that, we need to customize our Jib. So you can refer to the documentation here, extend usage. So we are going to follow some option to customize our image build. Okay, then first, remember, in the reverse, I just told you that we need to notice entry point, right? Entry point. Oh, by default, the default container entry point will be basically Java CP, class path. Remember that class path and the app main class. So let's see, we still have it somewhere. Okay, right, the entry point around it. So this is the entry point, the default one, Java and the class path files and the main class. So this is the default one, Java, class path and main class. So basically, you see, it's something like this. These files, the class path files and the main class file are generated and put into our Docker image for us. So we don't have to worry about the application code. So what we want to do here is we want to add this minus Java agent in our Dockerfile to this one. So let's say this is the default behavior, and the behavior we want is something like this, right? So we want to put this one before that, something like this, right? And this is the behavior that we want to customize our JB. Actually, it's pretty easy to do it in our case. We just need to extend. So gib here, then container gvm flags I'm going to add this one, Dockerfiles. So what we want to add this. So this is the default behavior. We want to add the JVM argument here. So basically just need to add this one, and that's it. So by config our JB like this one, we are going to reach the same behavior as our Dockerfile. Okay. Right. Now we were able to adjust the Java command as what we want. But right, we don't have the OpenTelemetry Java agent here in the images. Like in Docker, we have to copy it from our build directory to image. So then we have to do the same approach for our JB. And to do that, so in here we have to declare the extra directory. And in that, we're going to path from layout .build directory, right? Build directory. So the same directory is agent. Sorry, build directory agent, because we have to run the copy agent here. So clean and bootstrap, because bootstrap depend on copy agent, or we can run bootstrap, or maybe we can run directly the copy agent here. But okay, let's run bootstrap, and then we are going to have the agent. Then we're going from the agent and then into. So by that we are going to do the same thing as we did here. We copied, so we don't have to do this step, right? Because Jib already did it for us. Not the Java is going to have the main class, as we see. It's going to have the main class and the class path. So basically we don't need the jar here. We only need to copy the OpenTelemetry Java agents jar to Docker image. Okay. So build.gradle. So now everything in the agents, we are going to put it under the root directory. So in Java agent, so it means in the directory agent we have OpenTelemetry Java agent of jar, and we put it under this one, under root directory. Then this will end up like this one. Okay, to make it more easily, for example, we put it in the OTel agent. Then in OTel agent folder of OTel agent folder, we're going to have OpenTelemetry Java agent under OTel. So put everything under agent folder here to this folder, and that's what we're going to have. Okay, another thing that we know that, so now everything, to run Jib we need the agent jar here, so then we have to depend on p agent. So it's similar to bootstrap here. Bootstrap depends on copy agents. The Jib Docker build depends on copy agent. So now when we run the Jib Docker build, the copy agent will be run first. Then we're going to have this jar, and then the Jib Docker build is going to copy this jar to the OTel agent folder, and then we run with OTel agent. That's good, right? Let's refresh it. Okay, then we're going to stop Docker. And before that, let's try to increase our version into 0.2 snapshot. And our Docker Compose is now using two, right? Okay, so let's build our 0.0.2 clean reload the Gradle. Okay, lean, and I'm going to Jib Docker build. So now this is our container entry point, right? The Java, and this is what we expected. We want to put the minus Java agent here, and we keep the rest as same. Okay, so now it should work as we expected. With the base image is Alice Tamarind. So basically we trick the same behavior of our Dockerfile from Alice Tamarind, and then we can run this one. Now we don't need the Dockerfile anymore. I'm going to delete it. We can change it by Jib. Okay, let's back to application. Then we have another other service that have the service auto-implemented with OpenTelemetry Java agent. Okay, let's take Docker file now, run with the 7.2, right? Then we Docker PS. Took 30 seconds for your service to be ready to request. And now you see, yeah, everything at the log metrics. So log metric currently is logging the metrics, is logging the log exporter, is logging only the trace is going to send to trigger. At least we know that, so we successfully instrument our service. Okay, let's check it. So going to reload this one. So we have now all the service, and this, yeah, some create schema and data for us. So let's track to and back file trace again. Okay, so this is the root trend here, and now we have order 2. That's what we just sent. The order 2. Okay, so it's good. We now can containerize our auto-implemented services without using Docker files. Okay, so now based on your runtime, we can choose different Docker-based images. So for example, if we are going to deploy our service to AWS, we probably want to use Correcto. For example, so if we don't explicitly declare anything, so if we use Alice Tamarind 17, right? So now I want to use the Amazon Correcto because I want to deploy our service to Amazon, for example. I explicitly declare the from image. So basically, this is our base image, now the Amazon Correcto. The Amazon Correcto, you can find the latest version of the Docker image here. For example, the Amazon Correcto. I would like to find some base image for Java 17, then I will search for Java 17. Then, yeah, 17.0.9 output. So this is what we use here. Okay, so then let's see. For example, we increase our version and refresh it once. Clean. Then build it again. So now with the base image is Amazon Correcto. Right. Okay, let's see. Before that, we need to Docker. Then So we have this correctal base images. So the size is pretty bigger than others. And for example, I would like to deploy our service to Google service, for example, Cloud Run service. Then I may choose the distroless base image. For information about distroless image, you can find here. Example, distroless. For example, I would like to run Java 17. Then I'm going to find Java 17 Debian here, and this is the version, right? Okay, let's try to improve the version 4 and reload Gradle. Then let's try to build our service clean and build it. So now you see this is our base image, and let's run it again. So we have 004 snapshot, and the distroless image is really slim, right? It's much better than Amazon or maybe the default one, Tamarind Java, for example. And let's run it. So we still have to face the image platform doesn't match the detected host platform. Okay, platform here. So let's going to find platform. Okay, platform here, and this one. So we can use platform to select the base image that support the ARM here. For example, I'll copy this one. So it's the incubating features support design platform for manifest list. So for the manifest list, for example, of the base image, it should have support your platform, right? Then let's check this one. I'm going to our chip here. So now we are going to image and platform. Here because I'm run on my MacBook. So I think that's it. So I would like to get the architecture from the base image here and build from that. Select okay, refresh this one, for me increase version 5. I'm going to refresh this one, down file, and then let's refresh our Gradle. Need to refresh. Okay, clean and view our new images. Okay, we have other file, and then other file. So now it should work for my MacBook M1. Docker compose up -G. Okay, you see now everything worked without any warning or something. And docker log this one. So you see, it only took 2 seconds. It's much better because the architecture is now look good. So try to reload this, refresh. Okay, all the service without anything. Send 1, then send 3 to get error page. Okay, file trace again. File trace. Okay. So this is order 3. Then we're going to have the arrow, right? Arrow controller, arrow page, something like that. And so this is 1 without any arrows. Okay, let's sum up what we did. So we add Google Jib plugin here, and then we customize our JB to build a Docker image without the Dockerfile and can get the same behavior as the Dockerfile. Then we're going to update a little bit, change the base image to find the proper base image for its runtime environment, for example. That's it. And we can delete this one because we're not going to depend on that. Delete this one because we're using the refactor. Delete it because we're using the telemetry from this one, so we're not gonna use it. Okay, so thank you so much for taking your time watching this video and the series. Hope you can learn something new here, and see you in the next video. And as usual, happy coding.